Hi everyone. Today I'm going to replicate this model. It's in COMSOL. And this model comes from this research paper. It's a very famous research paper. You scroll down to figure 4, which is figure right here. I'm trying to replicate this. And I have all the parameters set up for the simulation already from the paper. I'm trying to get this figure and this figure right here. Go ahead and start it. I'm going to go to Model Wizard. Click on 3D. And for this simulation, it's a strain simulation. I'm going to click Solid Mechanics, click Study, and I'm going to choose Stationary. Click Done. Now in here, you're going to click on Geometry. You add the platform at the bottom. The width is 400. The depth is 500. And the height is 200. I'm going to choose Center. One. Now I'm going to create another one for the epoxy, which is have all the parameters right here. It's going to be 2200. Depth is 500 and the height is 10 micrometer. I'm going to go back and change this to micrometer. We are checkbox. We want it to be center. And when you build this, it's going to be like in the center. So we're going to move it up so that it's on top of the platform. We're going to build the sample. The width is going to be 1140. It's going to be 2228. And the height is going to be 10 micrometer. Now I'm going to move it up again on top of the epoxy, but outside the center. Here you go, center. Now we're done with geometry, we can add the material. So for material, the platform is in titanium. The epoxy is die-cast. And the sample itself is in a new material. So of course COMSOL doesn't have it. We have to add it manually. Click this, and the die-cast is going to be this one. Yeah. For titanium, according to the paper, the Poisson ratio is 0, and the Young modulus is 225 gigapascal, so 10 to the 9. The die-cast Young modulus is 4.5 gigapascal, and Poisson ratio is 0.3. For the sample, the Young modulus is 100 gigapascal, Poisson ratio 0.3, and the density is 4720. There you are. Now we're done with material, we can move on to physics. We have displacement on this part is going to be 10 micrometer, which is 10 to the negative 5 meters are going to become 10 micrometer. In the x direction, we're going to have another one on this side. It's going to be in the negative x direction. So the same displacement, but in the negative x direction. And we're done with physics. I'm going to go ahead and build mesh and click on compute. Now we're just going to wait for the simulation to work on this. Because sometimes it gives me this random error. And what I do for this simulation is I would go here, I add another fixed constraint for the bottom, and then I compute it again. Sometimes it happens, sometimes the error doesn't happen. So once I have this, I can disable this one. So go back to the original one and compute this. Here you go. Now you have this stress right here. Sometimes the error doesn't even appear, but I don't know. When it's appear, this is the solution. Now we have this one. Now you can go ahead and this is stress, it's not strain. We're going to add a 3D plot group. We click on surface, and we go back to the 3D plot group. We don't want to select the whole thing. We're going to select domain, and on the sample only. On the surface now is displacement. When I want a displacement, we're going to strain. For strain, click E, and then XX. We're going to have it in the X direction. Click YY. We have it in the Y direction. Now you compare with whatever in the paper, the color distribution looks correct now. It's not the same color, obviously, but the color distribution looks correct. I'm going to check the range, and the range is not correct. This is 0.8, while this is 1 to the 10 to the negative 3. The reason for that is this one is strain in the x-axis divided by strain x-axis apply. We didn't divide it first by AXX apply yet. We go ahead and divide it by AXX apply, and that is negative 20 to our displacement divided by the total length of this platform, so 2400. That we can have this one, and now if you check it, is go from 0.8 top here, 0 here, also 0, so that's correct. And if you go to EYY, we're going to see a correct version. Right. Top is like 0, 0. This is negative, 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 negative 0.3, negative 0.3 down here, and the distribution also looks correct. The color is a little bit different, but that's fine. Yep, and that's it for this tutorial. Thank you for listening.